Hi everyone. So I got a request to go through some Canadian exam questions. So I'm going to start with this one. Only 23.5% of students got this one right, even though it's multiple choice. So if you want to give this one a go, then pause the video here. Alright, so first of all, let's work out what it's saying here. Now, I was initially really confused by this question because I thought it was saying f of g of x. So f of, like that. But what it's actually saying is f times g of x. So that's just another way of saying f of x times g of x. So what I would do to start is try to graph this function like on the same axes. So one way to do that would be to just sort of look at various x values and put a dot where we find the y value should be. So for example, if we pick x equals 0, we know, like we can see here, we've got f of 0 is 2 and g of 0 is 4. So we know that h of 0 is going to be 2 times 4, so 8. And we can go on and do other values, like over here we've got 1 times 3, so that's 3, 0 times 2, so that's 0, -1 times 1, so that's -1, 0 again, and then -1 times -2, so that makes +2. And then over on this side, well, I mean it's symmetric, so it's going to be the same values as we had over here, just a mirror image. Okay, so we might think that it's going to have a shape sort of like this. And we could also test this algebraically. So instead of, picking various points, what we could do is try to find an equation for these lines. So we could do that like in two separate regions. Like in this region, so for x greater than 0, f of x will be 2 minus x, would be the equation of that line, and g of x will be 4 minus x. And then h of x is just the product of those. And then if you've got experience with graphing parabolas, you'd recognize that as a parabola that passes through 2 and 4 on the x-axis and would be upright, because when you expand that you'll get like a positive x squared, yada yada. So this is going to be just a parabola here. It's going to continue up like that. And then in the negative region you'd get a similar sort of equation. Okay, and then we're asked to find the range. Now range means what values y can take. So you can see with this graph of h of x, we don't have any y values down here, nothing below -1. In fact, we could test that it is actually -1, that's the minimum of that parabola. The vertex of the parabola, that turning point, is always halfway between the two intercepts. So we know it's going to be where x equals 3. And if we plug that into here, then we'll have 2 minus 3, which is -1, and 4 minus 3, which is 1, so -1 times 1. So yeah, definitely -1 is the lowest point on the parabola. So the range is just going to be, y has to be greater than or equal to -1, which is A. Okay, next up we have this question. Only 29% of students got this one right. So pause the video here if you want to try it. Okay, so I really love this question. I think this is a great question to test understanding of things. Now, just let's start with interpreting the question. So what does invariant points mean? Invariant literally means unchanging. So we're asked to find how many points there are that don't move when we apply this square root transformation. So what I would do to try to figure that out is like maybe try to graph this on like these same set of axes. Okay, so we just want to like take the square root of each y value. Now for these negative ones in here, we can't do that. That's not a real number. So you're just going to have like a big gap in the middle here. But then we could try seeing how some of these other points move. So, for example, this point here looks like it's just above 2. So the square root of 2 is like 1.4. So that's going to shift down to like there-ish, sort of. So that's 1 point on the graph of y equals root f of x. We could do the 0 is going to stay at 0 because square root of 0 is 0. So that would be one of the invariant points. And then we could pick a few others. I mean, okay, so that one's at 3. Square root of 3 is about 1.7, so, that one's up there, kind of. Another interesting one would be here, where y is 1. Square root of 1 is 1, so that's actually going to be another invariant point. That's just going to stay where it is. So far we've got 2 invariant points. You can kind of sort of see what this is going to be doing, sort of going off like that. And then in this region between 0 and 1, when you square root a number between 0 and 1, it actually gets bigger. So this is going to kind of curve up. It's a bit too small to see, but it's, yeah, can have that kind of shape. But it doesn't really matter because you can see that the only 2 points that are going to be the same on these two graphs are here and here. And then on the other side, over here, you'll have a similar thing, where the 0 is going to stay at 0, and the 1 is going to stay at 1. So in total, we've got 4 invariant points for that graph. Now, let's try it with this one. Okay, so we could just, pick a few points to square root, see what happens. This one is going to stay where it is, because that's at y equals 1, so square root of 1 is still 1, so that's going to be an invariant point. We could pick, I don't know, this one, which is like a 2, that's going to move down to square root of 2, which is like there. The 4 up here is going to move down to 2, because square root of 4 is 2. And the same thing over this side. And so, yeah, you can try a few points, and you're going to get this kind of thing where it's doing this. So you can see the only point that hasn't moved is this one. So there's only one invariant point for diagram 2. Now let's look at diagram 3. I mean, you might have seen the sort of pattern by now, that it's just the zeros and the ones that aren't going to move, because those are the ones whose whose square root is itself. Square root of 1 is 1, square root of 0 is 0. Any other point is going to get bigger or smaller. So with this one, all the points are going to get smaller. This 4 is going to move down to 2. Yeah, and so on. You'll get some sort of shape like this. So this one actually has 0 invariant points, because there's no point on this graph that's 0 or 1. So yeah, that's the answer to that one. Okay, next up we have this question, which only 27.8% of students got right. So pause the video here if you want to try it out. Okay, I'm just going to go through like every step to show how it all works. So personally, what I would do here is I would actually replace the cos squared x with 1 minus sine squared x. So I would say that's the same, and then this I'm going to replace with 1 minus sine squared x. And I actually made a video on trig identities like that. So I'll put a link to that up here. You can check that out if you like. And then, I'd simplify that and so on. What they've done is like equivalent, but not quite the same, where they've taken a sine squared x out of this, so split it up into 2 sine squared x plus sine squared x, and then they've combined these two together to make 1. So, that's pretty much the same. I just personally prefer that method. Okay, so up to here, everything's fine. And then they've just simplified this down, so 1 minus 4 makes minus 3, so that's fine. And then they've factorized this. To check that, you could sort of do the factorization yourself, or you could try expanding this to just check that it makes the same thing. So like 2 sine x times sine x, that gives the 2 sine squared x. And then we've got that times that is 6 sine x, and that times that gives a negative 1 sine x. So together those make the 5 sine x. And then we've got the negative 1 times the 3. That makes that. So that's all correct. That's fine. And then what they've done here is they've gone, okay, we've got two numbers multiplied together making 0. Therefore, at least one of them has to be 0. So either this is 0 or this is 0. So that gives you these two when you rearrange it. Now, so that's all fine up to there. This is actually the bit with the error, because they were asking for all solutions between 0 and 2 pi. Now, this one doesn't have any solutions because sine x can't be less than negative 1 or greater than 1. But this one will actually have two solutions. So if you want to see how to solve that, I go through this method in detail in my video on solving trig equations with exact solutions. So the way that I would do that is I'd draw up the unit circle. Sine is the y coordinate, and we want it to equal a half, so we go up to y equals a half. This is a circle with radius 1, so this is up at 1, so that's a half. And then we just draw in a horizontal line to represent y equals a half, and then where that cuts the circle is the two solutions, the two angles that we're looking for. So x is going to be this angle, which appears to be 30 degrees, or pi on 6. That's one solution, so that's the one they've got there. But then there's also this angle over here, which is going to be pi minus pi on 6, which makes 5 pi on 6. So there's actually two solutions to this equation. So the error is actually in step 6. So D is the answer to that one. And next up we have this question, which only 28.3% of students got right. Alright, so the first thing that I would do is rearrange this so that, because if I divide both sides by cos theta, then we're going to get a tan theta over on the left, because tan is sine over cos. So I would do that first. And then I'll give you tan theta is negative 2. Now we want to work out tan 2 theta. So you might know the formula for that, which is 2 tan theta on 1 minus tan squared theta. If you didn't know that, or if you forgot it, you might know the angle sum formula for tan. If you can remember that, then you can work it out. So that goes like that. So if you consider alpha to be theta and also beta as theta, then you'd get tan theta plus tan theta, so that makes the 2 tan theta. And then this is tan theta times tan theta. So you could get it that way. Or another way would be, you could think of this as being sine 2 theta over cos 2 theta. And then if you know the formulae for those, you could work it out that way as well. But yeah, let's assume one of those ways you work this out. And then we can just plug that value in, the negative 2. So we're going to get 2 times negative 2 on 1 minus the negative 2 squared. So negative 4 over 1 minus 4, which is negative 3. Remember that when you square that, those negatives will cancel. You've got negative 2 times negative 2, so that makes positive 4. And then we've also got that minus. So just be careful with all the negatives there. Okay, so we get negative 4 over negative 3, and then those negatives cancel, and we get 4 over 3. So that one's A. I'm actually not sure why so many students got that one wrong. Maybe if you know where you went wrong with that one, you can tell me in the comments what confused you about that question. And there is another way of doing this question if you didn't want to use that expansion for tan 2 theta. What you could do instead is actually work out what theta is. So we've got tan theta equals negative 2. So to work out theta, we can do inverse tan of negative 2. Now, not that it matters, but this one's actually in the wrong range. We need to be in that range. So to get that other solution, we can just add pi to this. If you want to like picture what's going on, you've got the unit circle and tan theta being -2. Tan is the slope on the unit circle, so let's draw a slope of -2. So you get these two solutions. So the calculator is telling us that one. We actually want this one because that's in the correct range. So we just need to add pi radians to that to work out that one. Or if you've got your calculator in degrees mode at the moment, I've got it in radians. You can't really see that, but there's an R there. If you've got it in degrees mode, you'd just add 180 instead. Okay, so now we've got what theta is. If we want tan 2 theta, then we could just multiply that by 2 and then take tan of it. And that will give us 4 on 3. So that's another way you could do that one. Alright, with this question, only 33.1% of students got it right. So pause the video here if you want to try it out for yourself. Alright, now the first thing that I would notice about this equation is that we've got powers of 5 here. This is 5 squared, that's 5 cubed. So what we want to do is, replace those with, replace this with 5 cubed. So let's do that. And then that's 5 squared. Okay, now exponent laws. One of the laws that you need to know is that if you've got a to the b and then you raise all of that to the power c, then you just multiply these exponents together. So with this, we're going to end up with the 3 times all of this. So we've got 5 to the 3x, x plus 1. Yeah. And then on the right, a similar sort of thing, you're going to get 2 times that. Okay, and then what we could do, use the rule here that if you've got like a to the b divided by a to the c, that makes a to the b minus c. So you subtract the exponents in that situation where you're dividing things. So we're going to get 5 to the this minus this. So I might expand this. 3x squared plus 3x. And then we're subtracting all of that. So like that. Yeah, you got to be careful about the negatives as well. Like you either want to put brackets around this, or you'd have to change this to a plus if you want to take the brackets out and expand it. So some people miss that. That was a weird 5. And then here we've got 2x minus 10. Okay, so now we've got, 5 to the something equals 5 to the something else. Well, the only way that's going to work is if this is the same number as this. So now we could just say, okay, that has to equal that. So let's simplify this a bit as well. That will cancel with that. And then when you expand this bit, you're going to get the plus 4. So we'll have 3x squared plus 4 equals 2x minus 10. And then they wanted it in this form, so we just got to shift everything over to the left. So we'll have 3x squared minus 2x. And then we'd be adding 10 to both sides, so plus 14. And then all they wanted to know was the value of c, so the value of the constant there, which is the 14. So C is the answer to that one. Now, this question was only answered correctly by 34.3% of students. So pause the video here if you want to try this one out. Alright, let's start with student A. So, the first thing they've done is they've pulled that 2 into the exponent here. That's fine, that's one of the log laws. Yeah. And then what they've done is they've used the law that says, if you've got log A plus log B, then that's the same as log A times B. So the plus becomes times. So that's what they've done there. They've done x squared times x cubed, making x to the 5th, so that's all fine. And then this step, they've done 5 times 3 here. Now that doesn't actually make sense. If you had log of x to the 5th and that was cubed, that would be fine, that would make that. But that's not what we have here. We've got log of x to the 5th, and then all of that is cubed. Now there's no law that says that you can just multiply these together to make that. So that's where we went wrong with student A, is in step 3. Now with student B, okay, so we've got 2 things added together here and they're cubed, and you can see that student B has sort of just tried to cube each part. So what they're thinking is like, okay, we've got 2 things cubed and that's just going to make a cubed plus b cubed. Now that's a very common error and it's not right. When you expand this, you'd have to use like the binomial theorem or something. It comes out as a cubed plus 3a squared b plus 3a b squared. You've got all these what's called the cross terms. I actually went over this in more detail in that question on the equation involving cube roots, so I'll put a link up to that here if you're interested in that. So that's actually where they've gone wrong here. They haven't included the cross terms, like they've tried to just sort of expand this wrongly using this misconception. So they've actually gone wrong in step 1. So that's the correct answer, C, for that question. All right, this one was only answered correctly by 33.3% of students. All right, so pause the video here and give it a go yourself. Okay, so what we can do is kind of like arrange the girls and the boys separately. So work out how many ways there are of arranging the girls and then how many ways of arranging the boys and like multiply them together. So if there's 3 girls, then the number of ways of arranging them is just 3 factorial, or 3 times 2 times 1. So like 3 choices for which girl goes first, and then 2 choices for which one goes second, and so on. So that gives 6, and then likewise the number of ways of arranging the boys is 6. Now, the kind of the gotcha with this one that I think probably tripped up most people is that you have to consider the cases where there's a girl first, like on the left, like girl, boy, girl, boy, girl, boy, that's sort of separate from boy, girl, boy, girl, boy, girl. Like, even if you're doing, you know, Emma is the first girl and Beth is the second girl and so on, and you've chosen the boys likewise, there's actually 2 ways of arranging them, because you could have the boy on the left, you know, the first boy at the left spot, or the first girl at the left spot. So just with this, we've got, so 6 times 6, so 6 ways of arranging the girls, 6 ways of arranging the boys, but then we have to do times 2 because of the choice of whether it's a girl or a boy that's like on the leftmost spot. So that would give 72, which is D. Now I think I covered a similar combinatorics question where there was sort of a similar sort of thing that would trip you up in my video. I think it was called Talent Quest Combinatorics, so I'll link to that up there if you'd like sort of more practice with that kind of combinatorics question. Now this question was only answered correctly by 21.2% of students. I think that's the worst percentage that I could find in the released questions for this. Anyway, so all right, let's start with maybe working out this length here. So you may know, you know, the formula for arc length is just theta times, you know, the angle times the radius. So 5 pi on 6 is the angle. 5 pi on 6 times the radius, which is 4 inches. So that bit's fine. If you didn't know that, or forgot it or whatever, you can think of it like the fraction of the whole circle is like 5 pi on 6 out of 2 pi. And then the total circumference of this circle, if this was a full circle, would just be 2 pi times the radius, which is 4. So then those cancel. That's where the theta r formula comes from. Okay, anyway, so that's that line. Similarly, this one will be the radius of this circle times 5 pi on 6. Now, I think this is where a lot of people probably went wrong, because I think what they might have done is use 16 as the radius. But the radius is the distance from the center of the circle to the edge. Now, the center of the circle is here. So we want this distance all the way from there to there. That's going to be the radius. So that's 20. So that bit's going to be 5 pi on 6 times 20. And then we've just got these bits. So, these bits here. Or I don't know, maybe another error that could have been made was maybe just not understanding the region that they wanted, that it's this white bit. Maybe some people included this bit here, I'm not sure. Okay, so these bits are just 16 inches each, so together they'd be 32. So we just need to add up these. And actually we could combine these two together to make 5 pi on 6 times 24. So I don't have to do so much typing into the calculator. And then we could simplify that. So 24 over 6 is 4. So we actually want 20 pi these would make together. So I've got my trusty calculator cam here. So 20 pi plus 32. And that makes 95. So D is the correct answer to that one. Okay, this one was answered correctly by 32.8% of students. Okay, so I think I can see where people went wrong with this one. Probably they thought that I0 might be the intensity of the vuvuzela, and that would give you the wrong answer. What it actually is that, let's call the intensity of the vuvuzela IV. So we know that that gave L being 127. So we could say 127 equals 10 log 10 of the intensity of the vuvuzela divided by the reference intensity. It doesn't really matter what that is. It's just like it's a very, very quiet sound intensity that we use as a reference. Okay, so we know that this is true. And then what does it say? The intensity of the vuvuzela is 5,000 times greater than the intensity of the lawnmower. So that tells us that the intensity of the lawnmower, let's call that IM, is 5,000 times smaller than the intensity of the vuvuzela. So we could say IV over 5,000 is what that is. So now if we want to work out the loudness for the lawnmower, we could say, okay, that's 10 log 10 of IM over I0, and then use this. So 10 log 10 of IV over 5,000 on I0. Now we want to be able to use this fact. So let's think about how we can kind of like separate this 5,000 out of here, if you know what I mean. So, I mean, one thing we could do is, this is equivalent to IV over I0 divided by 5,000. So think of it like that. And then we can use the log law about, division turning into subtraction. So this is going to make 10 log 10, actually let's put some brackets around that. 10 log 10 of IV over I0 minus log 10 of 5,000. And then you could expand this. So we've got 10 log 10 of IV on I0 minus 10 log 10 of 5,000. Now we know that this was 127. So we just need to work out 127 minus this. Now if you have worked with decibels before, you might like be so familiar with it that you could just sort of jump to this. Like the sort of reasoning is, okay, if we've got a 5,000 times decrease in the intensity, then if we work out 10 log 10 of 5,000, that's going to give us the difference in loudness. So we just want to do, 127 minus whatever that is. So if you've worked a bit in decimals before, you might sort of be used to doing those sorts of calculations. Anyway, let's work out what that makes. So 127 minus 10. Now, log 10 on most calculators is just called log. So we want to do that one. You don't want to use the ln. That's base e rather than base 10. And that gives 90 decibels. So that was C was the answer to that one. Alright, thanks for watching. Remember to like and subscribe and stay tuned for the next video.